Hello, everyone, and good morning, good afternoon, or good evening, depending on when and where you are watching our final video in the series on Singularity. Today, we are going to wrap up Singularity by discussing how we can use the module system that most high-performance computing environments have in order to make the containers more straightforward and easier to use. We're also going to touch on what is needed to run an MPI-enabled program using a container. And finally, as always, the way that this video will be structured, we're going to provide some context in the form of slides, and then we're going to end with an exercise that we're going to do on Quest, which is Northwestern's computing cluster. Okay, so why don't we get into it? So if we're being honest with ourselves, one thing that might be in the back of your mind, having watched the previous videos, is that the command line or the way that you call a container using Singularity is a little obnoxious. And so the idea here is that we're going to show how modules can help essentially wrap the call that you have that is required to call the container in a way that's much more familiar to us. Okay, so let's use our grep example from the previous videos as the foundation for kind of pinning down on this point. Okay, so if we wanted to call grep that was installed on the system, this is how we do it with the first line, okay, grep dash dash version. And if we wanted to call the grep program that was installed in the container, the way we would do it is with the second command line, okay? And so if we think about it, that's really extra just to call grep, the standalone program grep. So instead, let's imagine we wanted to be able to type the word grep and have it call the grep in the container, but we just type the command grep like we would to call the system installation of grep. So one way we might go about this is we might create a shell function or a bash function. And so I encourage people to look at my video series on bash for more information about bash functions. And so here on this slide, I make a shell function that I call grep. So I call the bash function grep so that when I run grep on the command line, the function grep will be called instead of the program or the system installation of grep. Okay. And so what ends up happening is that when I open a new shell session and I type grep dash dash version, instead of getting 2.2.0, I get 3.6 because now grep refers to the function grep, which wraps the container call to the program grep. And you can see if I unset or if I undefine the function grep, I go back to calling the system installation of grep. Okay, so the 2.2 version. So by leveraging shell functions, I can sort of reverse engineer the same experience that I get calling programs on the command line, but actually be calling the program inside of the container. Okay. So why modules? So you can imagine that writing out a ton of shell functions in your bash RC and naming them all and remembering what you named them could become quite overwhelming. So instead, what modules provide is a way to sort of load and unload and switch between versions of programs in a convenient way that requires less remembering on your part, okay? So what we do here is we create a module file for the program grep 3.6, okay? And inside of it, we load Singularity, we define the bash function, which is essentially a wrapper to the Singularity call, okay? And then we define a shell function called grep-container as that bash function, okay? And so now what happens is when I use this module that I defined locally and load grep 3.6, I have a usable shell function called grep container that I can use to call the grep that lives in the container. And then when I purge or unload the module, it also will unset or undefine the shell function grep-container, and it's no longer a command that's found or usable. And so this makes it very easy to switch between different programs that live in containers using the same like short, concise commands that you're used to using to call these standalone programs like grep or git or sed, etc. Okay. So we're going to show this in practice by defining a module that's going to wrap a call to Python 3, but a Python 3 installation that lives in a container. So we're going to see how defining the module will allow us to type Python 3 at the command line like we would normally when we log on to a computer, except when we type Python 3, it's going to be executing the Python 3 inside of the container instead of the one that lives on the system. Okay. So as always, I'm here on a Quest, and I'm going to go ahead and navigate to our shared working folder. And I have a folder for part 4 of our video series. Okay. And so the first thing that you want to focus on is the, first of all, you need to download or pull a container that contains Python 3 inside of it, the Python 3 that you want to use. If you remember from video 2, that container that we pulled was the Anaconda 3 Docker container. And so I already have that downloaded here. I'm not going to remake it or re-download it just because it takes a little bit of time. But so I've downloaded a container that inside has Python 3, and we can verify that by loading Singularity, entering the container in a shell, and typing which Python 3, Python 3 -- version. Okay, so there's a version of Python 3.8.8 that lives inside the container in the opt-conda bin Python in the folder opt-conda bin inside the container. Okay, so I'm going to exit out of the container and back onto my host system. So at this point, what you want to do is define a module. Okay, and we're going to call the module Python, which makes sense. And we're going to define inside of Python a file called 3.8.8.lua. Okay. And so now I'm going to define what does it mean when I module load Python 3.8.8. What do I actually want the system to do for me? And what I want it to do is to define a function called Python 3 that is some sort of bash function. Okay. And what is that bash function going to look like? That bash function is going to look like Singularity exec, and I need to mount the projects folder. Okay, because most likely I'll be running Python in the projects folder, so I want the projects namespace to be accessible to the container. Okay, and then I need to do the path to the container. Okay, so I'm going to get the full path to the container so that I can run this anywhere on Quest. If I just was to put Anaconda 3 latest, that would be a problem, because then I could only run the container inside of this specific folder I'm in right now. Okay. Anaconda 3 latest.sif. And then I want to have the program inside the container that I want to call. And then the key here is this $@ notation. So what this is going to say is it's going to define a function called Python 3, which takes in a variable number of arguments, and it passes all of those arguments to the $@ location in this command. Okay, so when I do Python 3 -- version, the -- version is going to actually be passed here to this Singularity call, as opposed to being passed to the Python 3 that lives on the system. Okay, and then finally, it's probably worth well, we can actually just end there. You can put a lot more stuff inside of a module if you want to, but this should be sufficient. Okay, and so what we want to do is we want to do module use, and we're going to use the modules defined here locally. And then I want to load Python 3.8.8. And if I do type Python 3, you can see that it's essentially defined a bash function for me called Python 3 that wraps my Singularity call. Okay, so when I type Python 3 -- version, I'm going to get 3.8.8 because that is the version of Python inside the container. So I get the same command line feel, even though I'm actually executing the container. So I don't have to do that obnoxious command line. I can just type Python 3 like I want to normally and still be able to call the Python 3 inside the container. So now if I do module purge and I type Python 3 -- version, now I'm going back to using the Python 3 that's on the system. Okay. And so that's really nice to be able to switch back and forth in a very simple manner. And so if I go back and I load the module again, I simply go back to using the Python 3 inside the container. Okay. And oh, I forgot one thing about the module. I knew I was forgetting one thing. It seemed too short. The final thing that you need to remember is you need to make sure that Singularity is loaded by letting it know that it depends on the module Singularity. So now I'm going to module load, and if I do module list, you can see that Singularity is also loaded when I loaded Python 3.8.8. And so now I'm going to do Python 3 -- version, and I'm using the Python 3 installed inside of the container. So hopefully you find this could be really useful for your workflows or for your shared HPC experience. I have found this a very convenient way to be able to use containers in a way that's familiar with how I use software that's installed as modules on Quest, so I can switch back and forth between them and have a pretty seamless experience. So finally, I'm going to leave people again with an example of what the module file looks like. And then also I'm going to leave you with an example of what it looks like to load that module, see that the bash function is created, and how when you then call Python 3, you are calling the Python 3 inside the container instead of normally when you type Python 3 at the command line, you would be calling the system installation of Python 3. Okay. Finally, people who want to have NPI enabled programs inside containers, the key thing is to make sure that your host system has an installation of NPI that matches at the major version level as that NPI you installed via apt-get or via yum or via whatever package manager you chose inside of the container. So if you have OpenMPI 4.0.3 on your host system and you installed OpenMPI 4.0.5 inside the container and compiled your program using that, that's totally fine. You can absolutely execute that NPI program on the HPC system that you're running on. Okay. So we're going to end there. Again, thank you so much for watching this video series on Singularity. If you have any questions as it relates to quests and using containers, please feel free to reach out to the Research Computing Services team. Thank you so much and have a great rest of your day.